Hello. In this video, we will cover how to do indexing with a Numpy array in Python. Okay, so we will learn how to import Numpy. We'll see how to do basic indexing of rows and columns and even elements. And we'll look at some other indexing methods as well. And finally, we'll look at an example where we'll try to create a stiffness matrix, something like this global stiffness matrix from a set of submatrices. Okay. So let's get started. First thing is to import Numpy. So we're going to say import Numpy as NP. We do this so that it's a short form for Numpy and we can use this throughout our code. Okay, so run this. And to make our life easier, I'm just going to import pandas as well as PD. And I will load a data file, data equal to pd dot read CSV, and we can then convert this data that you see over here, this table of values, into a Numpy array. You can just say a equal to data dot to Numpy. Okay, and let's look at how to index different parts of this array. You can create your own array. For example, you can just say b equal to np dot array. It's a function, and inside it you have to give it a list of lists where each list within the list is a row. So 1, 2 and 3, 4. Okay. So this is also a way for you to create your own arrays. So let's just deal with this matrix, this array A. So to index the first row, you have to use the square brackets and just put in the number for the index, for the row number. So it's 0 indexed. So the first row is A0. A1 will be the second row. A minus 1 is the last row, and minus 2 is the second last row, and so on. If you want to index from 0 all the way till, let's say, you want to skip the last row, you can just say 0 to minus 1. So notice that it always skips the last value. So if you say minus 1, it will not take the last number. Okay, so minus 2, it will skip this as well. If you would like to go till the end, you can just write it like this. And if you want to skip an element, you can define the step size after the second input. So this can be, let's say, 2. So it will skip every other line, so 0, 1, and then it goes to this line over here. Okay, this is how to index the rows. To index the column, you can just put a comma and say the next argument. So for example, if you say 0 to all, you get all the rows, but you just want, like, say the second column. So that's 1, 0, 1, 2, and you'll get the second column. Okay. Now you can see how you could find the element as well. For example, let's say I want this element here. So that's row number 2 and column number 1. So row number 2 and column 1, you get that number here. Okay. So these are different ways in which you can index rows and columns. In some cases, you might want to go in reverse as well. So let's say if you want to go from row minus 1 all the way to 0, you might write something like this. That's 1 all the way to 0. But this will give you an empty matrix because by default the step size is +1. So from minus 1 to 0, if you go in step sizes of +1, you're not going to reach there. So you'll get an empty array like this. So always specify the step size as well. So in this case, the step size is -1. Okay, so it goes in reverse. And so you can see it still skips the last one. So it skips the first row. You want to avoid this, just remove the 0 from there. Okay. Now let's look at other methods of indexing. Another method is maybe you just want the diagonal elements. So in this case, it's not a square matrix, but you still have a diagonal. So 0, 2, and 6, for example. Okay. You can get that by saying a dot diagonal. It's a function, and it will return the diagonal element. Okay. You can also have said np dot diag of a. You get the same result. You could also index from different parts of the matrix. It doesn't have to be exactly this. For example, let's say I want a subset 4, 5, 3, and 4. Okay. What you can then do is you can create an index value In this particular case, the index for this 4, 5, 3, 2 is going to be 0, 1 column and 0, 1 row. Okay, so I'll just specify this as row. 0, 1 and column. Just keep it interesting. Let's do column 0, 1. Let's do this subset 5, 3 and 4, 2. Okay. So the column has to be, so row is 0 and 1. This is row 0 and this is row 1. This is column 1 and this is column 2. So 1, 2. So you might try to do this A of, and then you can provide the row and column index over here, but you will notice something. Let's try to index it. So let's 0, 1 and column is 1 and 2. Okay. If you do this, Numpy is only going to get the following. It's going to get 0, 1, which is column row 0, column 1. Oh, we're looking at the inverse over here. Sorry, this is the right one. Yeah. So we wanted to get this column, which is row 0, column 1 and 2. So we were expecting 1, 5, 2, 9, but instead we get 1 and 9. Okay. The reason for this is it's Numpy is returning 0, 1. The first element is going to be 0, 1, which is row 0, column 1, this guy, and then it's going to return 1, 2. Okay, that's row 1, column 2, row 1, column 2, 9. Okay, so it kind of misunderstood what we wanted, or you could say that this is how Numpy is set up. Okay, this is the syntax for Numpy. This is what they do. Now to circumvent this, the only way you could do this is if one of them has to be a row and the other one actually has to be a column. So you can specify this as np.array, and you can have this as a column. So which means the first row is going to be 1 over here and the second row is going to be 2 over here. Okay, so you see how this is going to be a what do you call, a row vector, and this is going to be a column vector. Okay, now if you run this, it kind of works in the way we expect it to. But there is an easier way to do this. You can use the, let's reset it back. There is a command called np.ix, and then you can specify the row and columns, and this will, column, this will generate the following arrays for you in the right shape. Okay, and then you can then use this as an index for your matrix, and it'll be able to fetch the exact position from the matrix this way. Okay, you could also index this in another way as well. So let's create a copy here. So instead of specifying the row numbers or column numbers, you could have had a Boolean table as well. So for example, we have 5 rows, 1, 2, 3, 4, 5, and we want the first 2 rows, right? So we could have written true, true, false, false, and false. And for columns, we have 3 of them. We just want the second and third, so it's going to be false, true, and true. And if you run this, you should get the same exact result. Okay. Now you might not write out these Boolean arrays. This might be returned from different things like a pandas data frame. We're going to use this in one of the examples and show you how to put all this information together. So the example over here is this one. We would like to create this matrix over here, and this matrix here. This matrix is actually built up of smaller 2 by 2 matrices. You can see here. Okay, and each individual matrix is specified as this. We have 1, -1, -1, and 1 multiplied with some element stiffness for each element. Okay, and then they go to a specific position in this global set of equation. Okay, and you could, the way we plan to do this is the following. We will create a, so in this particular case we have 3 points or 3 nodes, so we will have a global stiffness matrix of size 3 by 3. Okay, what we will then do is we will place the element stiffness K0, for example, here, and everything else will be 0, and then you can just add this to another matrix of the same size, 3 by 3. Okay, and you could then add your other element stiffness K1 to the correct spots. Okay, and this should give you the final result. So this is how we will approach it. Okay, and we'll do this step by step. So the first thing is we need to be able to create this one. Okay, so let's look at how to create that one. So we already have our data. If you look at data, and it has to go in specific positions, and the positions are specified by the start and end node. Or element 1 is between 1 and 2, element 2 is between 2 and 3, so on and so forth. Okay, and the stiffness values are given here. So what we're going to do is we're going to use the pandas apply function to go through each row. So just define, let's say find stiffness matrix given a row, and then we can just say data.apply find stiffness matrix. Okay, and we're going to apply this row by row, so make sure you set the keyword argument access to be 1. So we want the row stiffness, so we'll say k equal to, or stiffness equal to row, and we will extract the column stiffness from it. Stiffness, okay, current stiffness. So it prints for us the stiffness value, so 5, 9, 6, 2, and 3. So it's printing out that. Now if you wanted this to be a matrix, you can just multiply this with np.array, and the first row is going to be 1, minus 1, and the second row is minus 1, comma 1. Okay, just to add some space between them, let's print a new line. So print /n, \n, this will create a new line so that you can separate these. So for every stiffness 5, for example, it's 5 minus 5 minus 5, 5. So everything seems to be working fine. Now we just need to put this, like we mentioned, in these blank matrices at the right spot. Okay, so for example, the first one is at 0, 1, 0, 1, specified by the nodes where it's connected to. Okay, so 0, 1 and 0, 1. The second one is connected at position 1, 2 and 1, 2. Okay, so row 1, 2, column 1, 2, because that's where it's connected, 1 and 2. Okay, so we'll have to use that information and put it in the right spots. Okay, so so let's first create a blank matrix. N equal to, in our particular case, if you look at this problem, you see that n is supposed to be, we have nodes from 0, 1 all the way till 5, so we'll have 6 nodes in total. So our n is 6. We'll create a k matrix, np.zeros, and you can specify the size using a tuple, so use this brackets, and then specify n comma n. Okay, and this should create a blank matrix like this, and our objective is now to push our stiffness, this smaller matrix, into this larger matrix. Okay, so we'll use the same indexing stuff that we just talked about, this part over here. So our index is equal to, our index is simple, our row and column are the same. Okay, the row is 0, 1, the row is 0, 1, and the column is also 0, 1. Okay, the row is 1, 2, and the column is also 1, 2. So we'll just call this index, and you can get the index as the start node and the end node. So we'll just say index is a list of where the element starts, and the element ends. Okay, so print index. So this is for the first one, 0, 1. The next one is going to be 1, 2, 2, 3, so on. Okay, now we'll use this information to change that particular location within your matrix to the stiffness. Okay, and this is easy to do. All you have to do is just say k. Okay, just like we learned here, k np.ix underscore, so np.ix underscore, and just give it the index for both the rows and the column. It's the same. Okay, and then you can change it by just saying this equal to and just plug in your stiffness matrix over here. And then if you print k, you can see that it's at the right spots, 5 minus 5 minus 5 5, and this sub matrix is now like shifted to the correct position. Okay, and it doesn't have to even be continuous, like for example 2 3. This could have been, for example, 2 0. Okay, you could change it in your data. Let me just show you, just as an example. You can say dot at so row 2 or index 2 and end. Let's change this number to 0, for example. Let's have a look at data again. So we change this to 0, and if you run this code, so yeah, in this particular case you can see it starts at 6, then it goes to 0. Okay, so it doesn't have to be in order. I just want to show this to you. Now the last part is to add all this up. Okay, so what you can do is then return all this into like a variable k dot all, for example. And if you look at this k all vector, you'll see that it's currently none because you're only printing the results. Okay, you should return these results. So use the command return k. Okay, so now you can see that all these matrices that you generated are now in a very nice what do you call it, pandas data frame, and each row corresponds to one large matrix. Okay, now to get the global one, this one, all you have to do is just add up all these things together and you'll get the final result. Okay, so we'll go back here and you can just say k underscore all dot sum. Just use the sum function and this will add up everything and you'll get the final matrix like this. Okay, just to confirm, you can see the last matrix was 3 minus 3, and here it's 2 minus 2, and this point should be 2 plus 3, and yep, you get a 5 over here. Okay, so this is how to create a global stiffness matrix, and by using the power of indexing in Numpy. Okay, so I hope this helps.